Hey guys, so for today's e-learning, we're going to be starting chapter 5 and talking about 5.1, which is properties of parallelograms. So a parallelogram is a quadrilateral with both pairs of opposite sides parallel. So a quadrilateral with both pairs of opposite sides parallel. So a quadrilateral meaning 4 sides. So this picture on the right here is a parallelogram. Let's say I named the vertices A, B, C, and D. In order for this to be a parallelogram, again, it says both pairs of opposite sides are parallel. So that means AB is parallel to DC and AD is parallel to BC. When you name a parallelogram, you use all 4 vertices, and you actually, just like with a triangle, you put a little triangle in front of it. With a parallelogram, you put a little parallelogram in front of it. So you would draw a little parallelogram, A, B, C, D. That's what you would name that shape right there. Then we have a few theorems. These don't have specific names, and they're pretty short theorems, but these theorems basically serve as properties of our parallelograms. The first one is that opposite sides of a parallelogram are congruent. So, again, we have another parallelogram drawn here. Let's say I called this one, we'll just go with ABCD again. According to this property, opposite sides are congruent. So side AB would be congruent to side DC, and side AD would be congruent to side BC. So segment AB would be congruent to segment DC, and segment AD would be congruent to segment BC. Also, opposite angles are congruent. Those are the ones that are diagonal from each other. So like angle A and C are opposite angles. So angle A would be congruent to angle C, and then angle D would also be congruent to B. So those are our opposite angles. And then our last theorem for parallelograms for this section is that the diagonals of a parallelogram bisect each other. So the diagonals aren't currently drawn in, but diagonals go, remember, from vertex to vertex. So you could have a diagonal going from D to B and from A to C. So if you have those diagonals, they bisect each other, which again, remember, forms a midpoint. So you would then have a midpoint there. And if you have a midpoint, then you have more congruent parts. So this basically implies that you would have a midpoint of your segments, and therefore these little segments would be congruent. So DM would be congruent to BM, and AM would be congruent to CM. So this implies that segment DM would be congruent to segment BM, and segment AM would be congruent to segment CM. So those are our properties, and we're just going to try out some examples using those. So first, just a couple true or falses. So every parallelogram is a quadrilateral. That is true. If you go up to the definition of a parallelogram, it is always a quadrilateral. B, every quadrilateral is a parallelogram. This would have to be false. A quadrilateral just means a 4-sided shape. So, I mean, it could really be anything, right? Something like that. It does not have to be a parallelogram. Just quadrilateral means anything with 4 sides. It doesn't have to be parallel or anything. And then for C, All angles of a parallelogram are congruent. That is false. They could be, but they don't have to be. Some examples of parallelograms that would have congruent angles would be rectangles, right? All four angles would be right angles or squares, but they don't have to have that property. And then all sides of a parallelogram are congruent. That is also false. The opposite sides are congruent, but there's nothing saying that all four sides have to be congruent. Next, we have an example where we're going to solve for some variables. I decided to give us one in the notes that had a system of equations so that we could practice that, because I know sometimes you guys get stuck on those. This one's actually number 22 in your textbook on page 170. So we'll skip that one in the homework. So we're going to solve for the variables, and we're going to do this using some of our new properties that we just learned. For example, we know that all of our sides our opposite sides are parallel. So this left side would be parallel to the right side. The top would be parallel to the bottom. Now, why would that maybe be helpful? Well, if you take a look at this picture, these are angle measures. We do know that the opposite angles are going to be congruent, but if you take a look, these are kind of being split up with our diagonals. So we're actually going to have a lot of alternate interior angles in this picture. For example, right here with x plus z and 85, that's actually a pair of alternate interior angles. So those would have to be congruent. So that could potentially be one equation you could set up. So one equation we could set up for our system is x plus y equals 85. Now, something to remember is I can tell that this is a system because there are two variables within one angle, right? Within one of my expressions, we have two variables. So that means I have to set up two equations, and then you can either solve with substitution or elimination. Now I need to figure out another equation I could use, and there are a lot of possibilities. One thing you guys might notice is maybe you could take your three angles here and add them up to be 180. That would be an option. Another option, what I'm going to do, and again, lots of options, what I'm going to do to try to keep this somewhat simple, if that angle in the center there is 130, then that means this angle here is 50. And then I have a triangle here with angles of 85 and 50, so I can add those up and subtract from 180. So 85 plus 50 is going to be 135. 180 minus 135 is going to be 45. So I know this angle here would have to be 45 degrees. And then I can use my other set of alternate interior angles that sits right here. So my other equation is going to be that x minus y equals 45. Now I'm setting this up to do elimination. This would also be a really great one to do substitution with if you wanted to, because you could easily convert this into x equals negative y plus 85, and then plug that in for x. So that's a good option as well. Totally up to you. I just tend to gravitate towards elimination. So since I'm going to do elimination here, remember what you do is you literally look for a variable to eliminate. A positive x and a positive x won't eliminate, but a y and a negative y will. So I'm going to cancel those out and then combine my like terms vertically. So x plus x is 2x, and 85 plus 45 is 130. And then I am going to divide to get 65. So that is my x. And then I just plug that back into either original equation to get y. So I'll plug that into the top one. 65 plus y equals 85. and subtract to get 20. Then there'll be a few systems ones on the homework, so let me know if you need help with that. And then last thing, we have a short proof, just to kind of give you an idea of how to use our new theorems and proofs here. So in this proof, we have that quadrilateral ABCD, or ABCD is a quadrilateral, or is a parallelogram, sorry, ABCD is a parallelogram, and CEFG is a parallelogram. So these are both parallelograms here, and one is laying within the other. We want to prove that angle A is congruent to F. So first thing, let's put down our given. A, B, C, D is a parallelogram, and CEFG is a parallelogram. That is given. Now, if we want to figure out a way to tie angle A to angle F, we're dealing with angles, so think about your new angle properties. One of the theorems we just learned about that has to do with parallelogram angles is that the opposite angles are congruent. So if you have two shapes within each other, something that we'll be able to say here is that angle C is congruent to angle A. But angle C is also opposite angle F. So in this little quadrilateral here, oh, and there should be the letter G right here. So in this quadrilateral, if C is congruent to F, because you have your little quadrilateral, and then you have your bigger quadrilateral, C is congruent to A, well then by the transitive property, we'll be able to tie A to F. So that's what we're going to do in this proof. So we're going to say that angle A is congruent to angle C, and we're also going to say that angle F is congruent to angle C, and that is because opposite angles of a parallelogram are congruent. And you can, write out the words if you want or abbreviate. Now, again, they're both congruent to C, so they're congruent to each other. So we can then say that angle A is congruent to angle F by the transitive property. Okay, so hopefully that kind of shows you a way to use some of these theorems here. Let me know if you guys have any questions.